Next up is Partpic. Come on up, Jewel. Okay, go for it.
All right. Hi, everyone. My name is Jewel Burks, and I am co-founder and CEO of Partpic. And Partpic is visual search for replacement parts. And our mission is to seamlessly facilitate the search and purchase of parts. And our team is built with ex-Googlers. So I came from enterprise sales at Google before transitioning into the industry at McMaster-Carr. My co-founder comes to us with experience selling to CPGs and Fortune 100s at Google, and most recently from the #1 mobile recognition company in the world, Shazam. And our CTO, Dr. Nashley Cephas, is a PhD in computer vision and machine learning coming out of Georgia Tech, which is the #1 school for digital signal processing. So we have a really great team to build out this product. So as mentioned, I started understanding this problem around part search as I was working as a sales manager at McMaster-Carr. And what I found was that customers were having a really hard time describing to us the parts that they wanted to buy. They were having to look through this 15-pound catalog for the parts they wanted to purchase, and it was causing a huge problem on the customer side and on our side. So I was actually able to monetize, or actually understand what was happening in that 40% of the customer calls originated without a part name or number, which led to about 6 hours per week lost in the part search process. And the bottom line for us and the other customers across, or companies across the industry, was about $10 billion lost every year because of miscommunication on the initial phone call. So with a deep understanding of the customer problem, I identified Partpic as a solution. Partpic is simple. It allows the user to snap a photo of the part they want to find, or 2 photos. We simply extract features from the part's image, create a statistical model, match that model to a part in our database, and return that to the user. And we are licensing this technology to distributors and manufacturers to put inside their mobile apps and on their websites to help their customers. So we are approaching the problems of, for example, in fasteners, which is our target type of part that we're starting with. It's very difficult to understand the lingo that certain distributors and manufacturers use to describe the fasteners. So example, ambiguous nomenclature around them. There are massive parts databases, and there's a lack of reliable images. So we're addressing all of those problems. And our approach is to ingest images, to classify them, to customize the extraction that I mentioned earlier, and to actually identify what exactly the part is. So this just takes you through the process of what's happening. And as you can see, we're looking at the exact dimensions of the part. We're not just telling a person that screw is a screw. They already know that part. We're telling them exactly what the screw is. So this is our solution for ingesting all the images into the database. So we've partnered with AVP Solutions, a company with 25 years of experience in image processing, to create this machine, to get all the database of parts built out. We can do about 1,000 parts per day with this machine. And the next piece of it is classification. So I won't waste too much time with that, but essentially we can understand quickly if a part is a nut, a screw, a bolt, and isolate the images we're searching based on that. And this just gives you a look at what's going on in the back end. Again, we're extracting the key features. We're looking at things like the finish, if it's threaded or unthreaded, what the thread count is, and using all of those things to create a statistical model and using that model as the match, creating basically a digital fingerprint for each part. We've patented this. This is an example of how Partpic will be used. For example, Partpic search on a retailer's website, just as image search, or how you're currently searching with a part number. Manufacturers, distributors, and retailers are our potential customers. It's a huge industry, $122 billion for MRO space alone, and they're going to kick me off soon. We're charging for the licensed technology, as I mentioned, an annual fee ranging from $250 to $500K per customer. For this longer tail of customers, we're charging on a per API call basis. And okay, yeah, that's pretty much it.
Thank you very much. Well done, well done. Julian, go for it.
Were you measuring from the consumer's photos, were you measuring the part, or were you returning the measurements? Were you using vision to say that's a 2-inch screw from their pictures?
Yeah, so we use a penny as a reference point for fasteners. And we're able to determine to about a 1/16 of an inch, actually even more than that, about a 100th of an inch. But our metrics, we go for 16 because that's the range that fasteners come in. They're by the 16th. And so yeah, we can tell.
How many customers?
So right now we're just launching with 2 fastener companies in Billings, Montana. We're working on a proof of concept with Home Depot as well. We have about 30 customers that have signed up on our website to use the technology, but we're just, the slide I missed out on is that we're just closing on our seed round of funding, $1.5 million. Joe Wilson is an investor. So we are just bringing on a full-time team to launch with the customers that have signed up.
David.
Are there categories of parts which are more expensive, which makes more sense to scan those first if you're doing 1,000 a day? Do you start with the 1,000 most expensive or most important parts or most highest volume? Or how do you think about what you scan first in your body of work?
So we get that question a lot in terms of why did we decide to start with fasteners when they're somewhat low dollar value. But even though they're low dollar value, they actually take up a lot of time for the distributors. So as I mentioned, I was working in the call center, and most of the calls that we got that ended up being 30-minute calls maybe have been for a $5 screw, but they still were creating a problem for us. So the idea there is that we can help alleviate all of those calls, we can help alleviate all of those return orders, and still going to create a big impact for the business. That $10 billion number was the number of, that was just the reshipping fees for the second orders. So even if the screw is $2, you still have to ship it, and there's still a dollar amount that's associated with that. So that's why we started out with screws, but we understand that that technology that we built can be applied to really expensive medical parts or car parts, for example. So we're going to be moving into those industries soon.
That was kind of
ahead,
my question was, what's this number of parts? You showed screws, but give us just a little bit of sense of what the parts kind of space looks like. What are the type of parts and sort of the complexity that you could actually ultimately address? Okay,
look around. Every single thing in this room is fastened. So fasteners is a huge industry. We don't think about it, but again, $122 billion in the U.S. alone for fasteners and $570 billion globally. That's just for fasteners. Screws, bolts, nuts, washers. So that's the market that we're addressing right now. Automotive is even bigger. So we're in New York, so not as many cars, but we're based in Atlanta. So tons of cars, huge space there for replacement parts, both on the aftermarket side and the dealerships as well. So yeah, it's a huge industry as relates to parts and what people are spending on replacement parts.
And the level of complexity that your technology can address?
Yeah, so like I said, we decided to start with fasteners because the differences between fasteners are so minute that typically it's difficult for an individual to tell which one they need, and again, causing a huge problem for the distributors and the retailers. But this technology that we're using, basically creating a fingerprint for each of these parts, can be applied across automotive. We've done testing with plumbing, done a little bit with the automotive space. We have a lot of interest in that area, so that's probably going to be our next big bucket. The complexity increases as we move into spaces like automotive, and we've even done discovery with Delta, for example. So aerospace, Department of Defense has reached out. So there's a lot of parts. We have a big challenge ahead of us as it relates to getting all of them in the database, but like I said, we built this machine, and machines 3 and 4 are going to be built larger to be able to accommodate the larger parts. So that's the plan there.
Who else down here?
Why'd you decide to license the software rather than building a meta search-based business?
So we decided to work with businesses first because we wanted to utilize the partnerships to build out the database before we release it to consumers. So the idea of going to the enterprise first and partnering with them to grow the database was just for that reason alone, that eventually we will release a consumer version of the app, but it's not going to be useful unless it's heavily populated with parts. So the idea, the goal is work with customers, and obviously it's also a better business model, I'd say, because we're going to have predictable revenue based on the customers we sign on versus throwing it out there in the world and hoping that consumers pick it up. So also it's easier for us because consumers are already purchasing from Home Depot, purchasing from Grainger, McMaster-Carr, some of the customers that we're working with. And they're going to do the work to get their customers to adopt the technology. It's going to be embedded on their websites, in their mobile apps. So it's not as much, we just have to sell to Grainger. We don't have to sell to Grainger's 22 million customers.
Julian, hang on a second. Anybody else that hasn't asked a question yet? You troublemakers in the back row? You all set? Go ahead, Julian.
Seems like it's going to take a long time to scan all the just fasteners. How long, and have you thought about creative ways to speed things up?
Yeah, so one point is that we don't have to scan all the fasteners. Our biggest, for example, with Western Builder Supply and Zander Fasteners, those are our first 2 customers, they send us 1,000 parts. We can scan them. It really took us like 3 days to do it. We can do it in 1 day, but that means one person working with no stops. So for business impact, in their case, it's only 1,000 parts they need scanned. Additionally, because we're using computer vision to do the extraction of the features and the measurement, we don't have to have every single screw. We just have a base part for each particular category, and we use that, and we can extract the rest of the features when the user takes the picture. So theoretically, for any large customer, we really just need like 5,000 to 10,000 of their parts, and that is representative of more like 200,000 of the parts that they sell.
Do you think there's a substitution risk from people just sending in photos of the part?
Well, so this is where I discovered the problem is that people at McMaster-Carr would ask, can they send us a picture, because they hated having the conversation. And what happened, if it was a great customer, like say Boeing, we would do the work, but they would have to send the part in, we would have to email it out and take it to the one guy in the warehouse who can identify parts just by an image. And then wait for him to be available to do that, and then find that part, and then get back to the customer. Maybe they'll answer, maybe they won't. So it's just not an efficient process. We're taking that system and making it happen within 5 to 15 seconds.
Okay, round of applause. Thank you very much. Good job.